Hello folks, we're starting our third last week in math here and in school in general, and we are now going into our final unit in math, which is about tessellations. And so it is related to what was most likely your first unit in grade 7, which is coordinates and design, because we'll be looking at a lot of transformations like translations, rotations, and reflections. So first off, you might be wondering, what is a tessellation? A tessellation is a pattern of objects that repeats itself that completely covers a plane, or in this case, you could consider your plane to be like the sheet of paper. And these shapes, they are interlocking. And so when we say that you are tessellating a plane, and that's a plane as in Plane, not as in I like my coffee plain. That means that these shapes, they will not have any overlap and they will not have any gaps between them. So in order to be a true tessellation, the point where all the objects meet must equal 360 degrees, as when you add up the angles of all those shapes. So for an example, let me do 4 squares right here. That's right. Okay, so just to show you this, so I've done the little I know this is not perfect. I did not use a straight edge, but pretend it is. I did the little squares in the corner to show 90 degrees, and of course every corner would be 90 degrees here. But you add up 90 degrees times 4, and that becomes 360 degrees. And so there are 3 regular polygons that you can use to create a tessellation. Those are our square right there, and you could also use really any kind of rectangle. But we also have, in addition to that, equilateral triangles and hexagons. If you have any other, by regular polygon, we mean that the sides of those shapes all have to be the same. Any other kind of polygon, like a scalene triangle, for example, where the different sides are all different. Well, different sides are all different, that's redundant. With a scalene triangle where all 3 sides are different, that would be an irregular polygon. So you can use all kinds of different shapes to create the tessellation. It's just that our squares or our rectangles, a rectangle that's not a square would not be considered a regular polygon, right? Because not all the sides are the same. So it would have to be a square, an equilateral triangle, or a hexagon are the only 3 regular polygons, or other irregular polygons that you can have it work that way. The key thing is that the pattern has to repeat. So if you're just putting in a bunch of different random shapes that are all interlocking, but the pattern is not the same, then once again you don't have a tessellation. So we look at the different ways that you can construct this. You can go very simply here. We see at the very beginning of the chapter, they throw M.C. Escher at you. And M.C. Escher was this Dutch artist. He lived from 1898 to 1972. He had very thick eyebrows, so very impressive. But even more impressive and famous than his eyebrows were his tessellations. And he was also known for doing illusions, putting illusions in his art. But with his tessellations, you see these amazing shapes that are interlocking, like light and dark colored lines that are all fitting into each other, and there's no space in between. And so we're going to be starting with some very simple shapes, making your own tessellations using translations, reflections, and rotations. And then in the final topic, you're able to actually explore and do some fancier ones. And it's really not all that complex. And they even will they show you Escher's, and they break it down into either hexagons or squares. And you see that, yeah, his patterns are essentially like a square with those lines colored onto them, repeating themselves over and over. It really kind of takes the magic out of it. Okay, so looking at translations, let's take a look at, I'm just going to do it very simply here on this paper. Let's say we have a square, just one square. It's my humble square here. I'll get rid of the other stuff. Okay, so we have this humble square. So what you could do, if you wanted to translate this, is you could snip it out. You could snip out that square and then trace it to have the exact same square over and over and over. And you would just slide it, up and down, back and forth, left and right. And by doing that, you could then create an image of all these interlocking shapes. It's lovely. Translation, right? So it's not, the orientation of it is not changed at all. Okay, so that's basically all there is to translation. You may remember translation was the easiest transformation because you're just moving left and right, up and down. The second form, which can often look the same as a translation in some cases, is the reflection. So this is an example that they actually have in your book, in the math book. And so I've got two hexagons I'm going to draw here together. And filling that space between the hexagons, I've got some triangles. So you can look at, if we look at the hexagons first, how did we get from one side to the other? Well, we could easily translate, move this hexagon just over here, and then just draw out an identical hexagon. We could also reflect it, because if you flip this as the mirror image, because it's identical, it would just be the same hexagon flipped over on the other side. If you had some kind of color inside the hexagon, though, then it might look a little different. It might look like, wait for it, it might look like this, right? If you reflected it and there was some kind of color inside. But now take a look at the triangles, because you could do either reflection or translation to move those hexagons, but with these triangles, you'll notice that the orientation is different. The pointy side is gone from the top to the bottom, pointing down to now pointing up, or pointing up to now pointing down. So in this case, you have to do a reflection, right? Because, oh, I'm covering it up here, because if you're using this pen as our plane, as a mirror, it flips over top. So I'm going to actually draw, I'll do a little dotted line to show you that reflection. And I'm going to put some vertices here just to demonstrate this. So you may remember with reflections, basically you count from each vertex, each point, down to the mirror, and then you're going to move that same number of spaces, or the same distance in this case, away to create the mirror image. So for our dot here at the bottom that is right on the mirror, then that will not change spots because it's already there. It will be on the mirror still. But for these other two up top, you can count, if we went like 1, 2, you'll go 1, 2 down, 1, 2, and 1, 2 down. So if we give these letters, if we called it triangle ABC, then we'll see here that our new points are called A prime, B prime, and C prime. So C prime is going to be, if C prime is the bottom, will be the same location as C. A will be the opposite location as its mirror image, A prime, and same with B, reflects down to B prime. And now, of course, if we had, if we were reflecting the hexagons, then the mirror line right here, if you can see this, would be a vertical mirror. Okay, so that's how we reflect. And now, of course, you can also have, if you wanted to, this is really more complex than typically we would do in grade 7. Grade 7, your mirror lines were either vertical or horizontal, but you could just as easily have a diagonal mirror line at any angle. It's just when we were working with the Cartesian plane, you know, that's a little bit trickier. Okay, so the last type of transformation, you may remember, this was, I would consider to be the most difficult part of all of grade 7, was the rotations of shapes. The whole visual awareness, spatial awareness was really challenging for people to get that, especially depending on where that point of rotation was. Basically, for our rotations on a tessellation, you are going to be considering one of the vertices to often be the point of rotation if it's connected. Now you could just as well, I don't want to speak prematurely here, because let's say, for example, let's say we have a pattern with a hexagon and we have a bunch of triangles around it. and these triangles are pointing in different directions. Well, here you could potentially, you could potentially use translations or reflections, but but also you'll see with some other shapes, like let's say, you know what, hexagon was maybe not a great example. Let's use an octagon because we have more different angles there. Okay, here we go. Yeah, now we're cooking. Okay, so here, take a look at this. Okay, we have this octagon. Oh, I'm covering up the one thing I want to show you. Okay, so right here, we have this octagon, and we see the triangles are pointing in different directions. So it's some sort of rotation. In this case, the point of rotation would not actually be attached to the triangle itself, but the point of rotation would be right in the center of the octagon, right? Like kind of like the center of a clock as the hand rotates. But now if you had, let's say, 4 squares, you could consider, if you wanted to think of this as a rotation, all the squares of equal sides. Of course, it could be a translation or a reflection too. The point of rotation in this case, if you were doing a rotation, would actually be connected to those squares. It would be right attached in the center. Okay. So with those rotations, the difference is, unlike grade 7, we're not really going to be using a Cartesian plane. So when you're rotating something, you basically, you'll know 90 degrees, 45 degrees, 180 degrees, those multiples of 90 for sure, because that just goes like from here, kind of like going from 3 to 9 on the clock. But yes, we're not really plotting stuff on the Cartesian plane for this. And so that actually covers rotation. So there are a few practice questions there. Ultimately, for all 3 transformations, you're going to get your real practice and application of it in our tessellation project. Before I get to explaining that, though, we have one more section, and that is talking about how to actually do MC Escher-Style Tessellations. And so pretty much you'll see, we're going to uncover his secret. And so let's say we wanted to have a fancy shape. Okay, so we're going to start though with one of our basic regular polygons. We're going to start with a square. Right here. What you can do to make it a fancier shape that still interlocks is, let's say we're going to design a little bit of a curve here. And we're going to actually, what you can do is take this, cut it out, and then tape it to the other side here. So you'll have a fancier shape. So when we do that, it would look like the following. Okay, oh my goodness, I don't want to mess up here. No, I've come too far. Okay, here we go. So you'll see that it should look something like this. So you've taken this side and you've now taped it here. And then you can continue to draw this and to trace it. So these patterns this shape all fits into, these shapes fit into themselves. Sorry, I was just wanting to get my plural and singular conjugations there correctly. And so you can see the example that they provide actually at the beginning of 12.4 on how to do something precisely with that shape. But then, okay, it's still a bunch of shapes. How do you get it to look beautiful? Well, what you would want to do then is have some kind of design inside that shape. So for example, we can talk about the lions. I'm going to draw a lion here. Oh my goodness. Okay. So if I draw something dark, and might even be better just to plagiarize, okay, and then you'll see that in this case, okay, so it doesn't really look like a line at all. In fact, it's just a blob of color. But then when you have the next one, which is identical, fitting onto it, like let's say this was the head of the lion, okay? Let's say this is the head of the lion, and this is the tail. There we go. And then this is a dark lion, and this is its tail. Okay, so as you are connecting these, you'll have another tail attached here with another head, and it'll continue on, lines after lines, fitting into each other. Okay, so it's not really all that complex once you break it down into those steps. And of course, that's basically just the example they give you in the textbook. You could have it be any other kind of shape, any other kind of design within that shape to make it look really beautiful. And now, of course, you don't really, if they are asking you to make a real tessellation in the textbook, if you want to, that would be lovely. You could even send me the hand-drawn stuff, but you don't have to. Because you'll be doing the actual tessellation project in lieu of a test. There's no test for this unit. And so this will be computerized. So part of the challenge, you'll notice in the instructions, is that I don't tell you, here's what to do in the program. In fact, I don't even tell you what program it is. Probably Google Slides would be the easiest, I'm thinking, because you could do insert shapes. And then when you insert the shape, you can then color it and fill in a shape with some kind of image. I don't really work a lot with the Google programs. I tend to do more Microsoft Office. But with whatever software you have, you're basically looking to have a series of interlocking shapes that form a repeating pattern. And so in the instructions, it says I'm looking for three things. I'm looking for a translation pattern, a reflection pattern, and a rotation pattern. One thing I don't mention there is you don't necessarily have to do 3 enormous tessellations. You could actually even encompass all 3 of those things in one tessellation. You could have something that's considered a rotation, a reflection, and a translation within the same image. And in fact, even with the same shapes, you could say, as we saw here, that the same transformation could be a reflection or a translation. Your rotation, though, shouldn't just piggyback off of the reflections or the translations, because I know it could, but I do want to see you challenge yourself a little bit more so that perhaps it's like a 45-degree angle instead of just a 180-degree angle, which would be the same as a reflection. So you can have explanations. You can include some notes along with your tessellation that show that, okay, here's my understanding of how I got here. And so there's artistry as well. So basically just have it be pretty. Don't just leave it as a regular boring shape. So you can just fill it in with some kind of pattern. Look to maybe repeat that pattern, and then you're off to the races. Shouldn't take that long. I'm looking for you to completely tessellate or tile the plane, meaning that there shouldn't be any blank space left over. There shouldn't be overlap of your shapes. There shouldn't be gaps in between. So you'll just have to be mindful of that, and don't be sloppy. And so this is very low pressure. If you've done everything you're asked, 100% for this unit, no worries about a test. Okay, so if you have any questions, please feel free to contact me. This concludes not just our math chapter, but our entire math course for grade 8. So it's been an honor to teach you and to enjoy just how hard you've been working and all your great questions. And when I've made some mistakes on the whiteboard up there, you guys have been there to catch it. You know, I try to do that to keep you sharp, right? And so I will plan to post a final aftermath video, pardon the pun, but this concludes it for the math lessons. And so all the best to you, and have fun with some of those tessellations. Let the inner artist within you shine without. Bye-bye.